Hello and welcome. Show that the sequence 12, negative 6, 3, minus 3 over 2, tap, 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 okay, is geometric. The dots, okay, shows that the given sequence is an infinite sequence. That is, it is an unending sequence, okay? And we are asked to show that the sequence is geometric. That is it true that the numbers 12, negative 6, 3, negative 3 over 2 form a sequence known as a geometric sequence? A geometric sequence is a sequence whose terms increase or decrease by a constant ratio, which means if the ratio of any term to the preceding term is a constant ratio throughout the sequence, then the sequence is known as, we have a sequence known as a geometric sequence. So which means a geometric sequence is a sequence which is characterized by what we call common ratio. All right, let's find out. Then the second question is for us to find the nth term. Use subscript n represent nth term, and hence write the 13th term as a rational number. Now, when we talk about rational number, a rational number is any number that can be written in the form a over b, okay, with b not equals to 0, okay, with b not equals to 0. Very important. Okay, all right, so we want to show that the sequence 12, negative 6, 3, minus 3 over 2, okay, tap, 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 okay, is geometric, okay. And I said for a sequence to be a geometric sequence, it means that it means the ratio of any term to the preceding term will be a constant, will be a constant ratio throughout the sequence. So we'll give now to show that 12, negative 6, 3, negative 3 over 2, okay, is geometric. Remember, I said a geometric sequence is a sequence whose terms increase or decrease by a constant ratio, okay. And I said that is if the ratio of any term to the preceding term is a constant ratio throughout the sequence, okay, then the sequence or the given sequence is a geometric sequence. The given sequence is a geometric sequence. So this constant ratio, we need to find it. Find the constant ratio. We want to know if the ratio of any term to the preceding term, okay, is a constant ratio throughout the given sequence. And like I said, a geometric sequence is a sequence which is characterized by what we call common ratio. So we know that common ratio, formula for common ratio, that R is equals to U subscript n, which is the nth term, divided by U subscript n minus 1. So which means when n equals to 2, we're going to have the common ratio to be U2 divided by U2 minus 1, which is U2 over U1. Also, if we have at n equals to 3, then we have U3 divided by u3 minus 1, which will be equals to u3 over u2. Now, u2 is the second term, which is negative 6. u1 is the first term, which is 12. And if we divide negative 6 by 12, we'll get negative 1 over 2. u3 is 3, which is the third term. Okay, the third term is 3, and when divided by the second term, which is negative 6, then we're going to have that to be negative 1 over 2. So we have a constant ratio throughout the sequence. So the numbers 12, negative 6, 3, minus 3 over 2, tap, 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 is geometric. That is, they form a geometric sequence. So we can say, therefore, the terms 12, negative 6, 3, negative 3 over 2 form a sequence, form a geometric sequence, a geometric sequence whose first term is 12 and common ratio, okay, is negative 1/2. Okay, so that's the answer to the first question. All right, the second question. Okay, we are asked to find the nth term, and hence write the 13th term as a rational number. Of course, to find the nth term, because we just got to know that the sequence is a geometric sequence. Now we know that to write the nth term of a geometric sequence, okay, the nth term of a geometric sequence, we have that to be u subscript n to be equals to first term multiplied by the common ratio raised to the n minus 1. Okay, all right, so to write the nth term of this sequence, now we know that the first term is 12, the common ratio is negative 6. Okay, so it means that the nth term will be 12 parentheses minus 1 over 2 raised to the power of n minus 1. So this is the formula for the nth term. That is the nth term. Now, also we are asked to write the 13th term as a rational number. Okay, so for 13th term, okay, that is when n is equals to 13, we're going to have u subscript 13 to be 12 multiplied by negative 1 over 2 raised to the power of 13 minus 1. Okay, so this will be 12 multiplied by negative 1 over 2 raised to the power of 12. Now, in this case, we have the common ratio to be negative 1 over 2, okay, which is raised to the power of a positive and an even positive integer, okay, or yes, a positive even integer, okay, a positive even integer. And when we have a negative number raised to the power of a positive even integer, okay, then it means it's going to give what? Positive. So in this case, this is same as 12 multiplied by 1 over 2, okay, raised to the power of 12. Okay, so that this will be 12 divided by 2 raised to the power of 12. Now we know that 12 is 4 times 3, okay, and 4 can be expressed as a power of 2. Okay, that will be 2 to the power of 2. So we have the 13th term. Okay, the 13th term will be equals to 2 to the power of 2 multiplied by 3 divided by 2 to the power of 2 multiplied by 2 to the power of 10. So when this cancels this, then we'll be left with 13th term equals to 3 over 2 to the power of 10. Now, 2 to the power of 10 is 1024, okay? So which means that the 13th term is equals to 3 over 1024. And we can see we have this written as a rational number. The noblest pleasure is the joy of understanding. Bye-bye.